Okay, another example from section 4.7, applied optimization problems. Which point on the graph of y equals 4 minus x is closest to 2, 1? Okay, so let's just draw a picture of this graph to get an idea of what's going on. Okay, so let's get ourselves an x and y axis. Okay, y equals 4 minus x. That is a line with a y-intercept of 4. So 1, 2, 3, 4. And draw a point there. There we go. Okay, and a slope of -1, -1x. So I'm going to go give myself some tick marks here. And I'm just going to plot some points. Okay, so down 1 from the y-intercept, down 1 to the right 1, down 1 to the right 1, down 1 to the right 1. Okay, so just getting some points on the graph. And that's way more than I needed. Okay, so let's draw ourselves a line that goes through those points. That one doesn't quite work. Let's just draw it with the pen. Okay, so there's my line-ish. Okay, and then the point 2, 1. So there's 2, 1 sitting right there. Okay, and we're trying to find the point that is closest, and it looks like it'd be about right here. Okay, the point on the graph of y equals 4 minus x, I'll call that x, y. That is closest to this point 2, 1. Okay, so we are basically trying to minimize the distance here between 2, 1 and x, y on my line. Okay, so I want to minimize distance. Okay, so the distance between 2 points, we have a distance formula, which is x2 minus x1 squared under a radical plus y2 minus y1 squared. Okay. So that's what we want to minimize. All right, so let's just plug in our 2 points. We're trying to minimize the distance between our x, y and our 2, 1. Okay, so our distance is square root. I can do x minus 2 squared. So I was just subtracting my x minus my x, and now I'm going to subtract my y minus my y. So plus y minus 1 squared. Okay, so there's the formula that I'm trying to minimize. So we want to get that down to one variable so we can find its critical values. Okay, so I'm just going to use this y right here that's in the formula. We know that that is on the line y equals 4 minus x. So I'm just going to replace y equals 4 minus x in my formula. So I've got x minus 2, y equals 4 minus x. Okay, and then I've got a formula that's just in x, and I can simplify a little bit here. I've got a 4 minus 1. I can make that into a 3 minus x. Okay, in a little bit I'm going to want to FOIL that out and kind of simplify it so that I can find its critical values. But first, now that we've got this down to one value, we need to pick our reasonable interval for the variable. Okay, so our only variable in our distance formula now is x. Okay, so remember x is our x-coordinate of this point that I've got circled in pink. Okay, so that's, it's going to be somewhere here. Okay, we just need to put some limits on that. Okay, so clearly this point is somewhere along this line in the first quadrant. Okay, and those x-coordinates cover x equals 0 to x equals 4. Okay, so I'm just going to pick that as my interval. Okay, so x is somewhere between 0 and 4. That's obviously going to be where the closest point is. All right, so now let's kind of simplify. I'm going to keep this big radical, and I'm just going to FOIL out x minus 2, and 3 minus x, 3 minus x. Okay. So I've got, let's see, that's going to give me x squared first, outer, inner, last. That's my first FOIL. And then my second one is going to be 9 for my first, outer, inner, last. So that's my second FOIL. All right. So I'm going to combine all of my like terms together. Got a lot of stuff going on here. Okay, so I'm going to come over here on the left and just try to simplify that a little bit. Okay, so I've got x squared and another x squared. So I've got 2x squared. I have got, what do I got over here? For my x's, minus 2x, minus 2x, minus 3x, minus 3x. That's going to give me minus 10x. And then my constants, I've got plus 4 plus 9, so plus 13. Okay, so that's my distance formula. All right, so I'm going to get rid of all this stuff over here now. Give myself some room. All right, so I've got that distance formula over there, and I'm trying to find its minimum on the interval 0 to 4. Okay, so I need to find the critical values of this function. So I'm going to rewrite it as 2x squared minus 10x plus 13 to the 1/2. All right. So I need to find, and again, we're doing that on the interval 0 to 4. We picked that. Okay, so let's find the critical values of our function. So we're going to find the derivative of our distance function. All right, so we're going to need the chain rule. We're going to take the derivative of the outside function first, leave the inside function alone. So I brought down the 1/2. I'm going to subtract 1. 1/2 minus 1 is a negative 1/2. Then I'll take the derivative of the inside function. Derivative of that quadratic is 4x minus 10. Okay, so then let's just simplify this. I'm going to take this business down to the denominator. Okay, so all I have left up top is the 4x minus 10. Okay, the 2 from the 1/2 is already down in the denominator. And then this stuff to the negative 1/2 we can bring down as 2x squared minus 10x plus 13 to the 1/2. All right. And I want to figure out where that is equal to 0, right? Our derivative, we're going to set it equal to 0. Okay. So remember that if you've got a fraction set equal to 0, we just need to figure out where is the top equal to 0. Because if the top is equal to 0, 0 over whatever is going to be 0. Okay, so all I really need to do is make 4x minus 10 equal to 0. Add 10 to both sides. Divide by 4. And reduce that to 5/2. Okay, so my critical value is x equals 5/2. Okay, so remember that we are going to test that in our distance formula, and we're going to test both of our endpoints from our interval 0 to 4, and we're going to see which one gives us the minimum distance. Okay, all right, so let's clear all of that out. I'm going to save my little critical value down there. All right, so I'm just going to find my function value of my endpoints. We're on 0 to 4, so d of 0, d of 5/2, and d of 4. Okay, so we're just going to plug in and plug in 4. Okay. All right. So we just need to figure out what those are. That one's pretty easy. That one gives me the square root of 13. The bottom one is also going to be easier than the middle one because it doesn't have fractions in it. Okay, so this one gives me 2 times 16, okay, which is 32, minus 40, which would be negative 8, plus 13, which would give me 5. So that one gives me a distance of the square root of 5. This one, I'm going to need a little bit of scratch work here. So let's kind of come down, do a little bit of scratch work. So I've got 2 times 5/2 squared. That'll be 25 over 4. Minus 10 times 5/2. Let's see, the 10 and the 2 can cancel. That'll give me 25. And then plus 13. Okay, so my 2 and my 4 can reduce. I've got 25 over 2 minus 25. I can write that as 50 over 2, and then 13 I can write as 26 over 2, just so everybody's got a 2 in the denominator. Okay, so that gives me 25 minus 50. That's negative 25 plus 26 is 1. I just get 1/2. So this distance here in the middle is square root of 1/2. Okay, so again, all we were doing there, we were pretty sure that that 5/2 was our point. We were just verifying that the distance was minimized at 1/2. At 5/2, and that's the smallest value that we get on that interval. So let's go back to our graph. I kind of made a mess of my graph, so I'm going to regraph my function. Okay, so we had our graph. Four minus x. Wow, that was terrible. Okay, here's the point 2, 1, and here somewhere. All right, and we found the point at x equals 5/2. Okay, so that's 5/2 is right there between 2 and 3. All right, and if I go up to the line, 5/2, I get this point here. Okay, and then to find the y-coordinate at that point, I just need to plug it into the equation of the line. Y equals 4 minus x. So y equals 4 minus 5/2. Think of 4 as 8/2. And you get 3/2. Okay, so that's my y-coordinate, 3/2. All right, and 3.5 is 1.5. That actually looks exactly like where that should be. All right, so that's your answer. That is the point on the graph of 4 minus x that is closest to the point 2, 1. All right, that's it for this one.